So if you are doing a photo log for this course, I would love to see a picture of a rainbow. I love rainbows. I'm going to be a little redundant probably on some of these slides, but in order for a rainbow to occur, you need 3 major requirements. 1, the sun needs to be low on the horizon, so that would be either near sunrise or most likely near sunset. Let's see, what else? You need to have suspended liquid water droplets, kind of like mist. And so a very common way to get liquid water droplets like hanging around in the atmosphere would be kind of rain in the distance. And that sheet of liquid water droplets needs to be on the horizon opposite the sun. And between between the sun and those liquid water droplets, it needs to be clear, no clouds. So that's quite a bit of stuff. So, for instance, let's see, if this is the sun low on the horizon, then we need to have some sort of, maybe even kind of lingering last-minute precipitation over here. You could have your dark clouds over here. And actually what we're going to see then is you need to, this would be another requirement, I think, you need to be facing this direction. So your back needs to be to the sun, and you need to be facing, and there is where you're going to see your rainbow in the suspended liquid water droplets. I have some miscellaneous videos about rainbows that I really like. So I mentioned this, to see a rainbow, then you're going to be looking towards those water droplets and away from the sun. The sun's going to be at your back. And if you see a complete rainbow, it will extend a good 85 degrees. Sometimes you know that there's a primary rainbow and a secondary rainbow. You'll always see the primary rainbow, and if you can get a picture of a secondary rainbow, go for it. Okay. So we don't always have secondary rainbows with our rainbows. This is kind of a fun thing that you will always see from inner to outer colors. So like, let's see, looking at the rainbow, just kind of like there, that's the direction of my arches. Let me do this. My arching rainbow. So I have the sun to my back, and there must be some sort of liquid water droplets kind of making that, giving me a rainbow in the other horizon. So from inner to outer, it goes like this. The shortest wavelength here, Vib, G, YOR. So the longest wavelength on the outside. Now if you see a secondary rainbow, it'll be kind of outer. So that was my primary rainbow, and my secondary rainbow is out here, and actually the colors are going to be reversed. So you are going to have the inner one's going to be red, orange, yellow, green, blue, indigo, violet. This is my secondary. This is my first, my primary. There you go. Isn't that beautiful? Rainbows totally rock. So again, you see the red on the outside, the violet on the inside for the primary rainbow. Red on the outside, violet on the inside. Just a part of a rainbow. So we talked about refraction before, and I mentioned that refraction, in those cases, all components of light were changing direction together. But what a prism does is make use of light changing from air to glass, and then back from glass to air again. And it is in just the right configuration that basically your components of light are refracted differently. Okay, specifically what we're going to see is that red light is bent the least. Red light is bent the least, while the shortest wavelength, violet light, is bent the most. So for that reason, you see the red has most closely the trajectory of the entering light, and then the violet is bent the most. So here, wavelength, remember the symbol for wavelength is that lambda. Wavelength does matter, and it makes a difference as to how much refraction will occur. And so basically, what a prism does is break white light out into its components. So let's look at the physics of a rainbow. Here on the next slide, what you're going to see is that light enters the water droplet, and that we have, there are actually two refractions that occur. There's a first refraction when water goes from the air into the liquid water droplet. Then this is so cool. This is so complicated. I don't think it's that complicated, but it's really neat. And that light is, after the first refraction, is reflected off of the back of the rain droplet, and it kind of bounces around there. And then when it goes to leave the droplet kind of in the direction it came from, it is going to be refracted one more time. So here we go. Here is the incoming rainbow ray, and notice it's going from air to liquid water. And then notice the refraction. It goes back here. This is the reflection that I was talking about off of the back of the rainbow, off the back of the water droplet. And after reflection, notice we have the light is refracted or bent, and here we have one more refraction, second refraction. Isn't that cool? And what you're going to see is that the red is going to be refracted 42 degrees when the dust finally settles, and the violet is only going to be refracted 40 degrees due to kind of the double refraction. Okay, so you can kind of see the consequences of that, the 42 versus the 40. Well, when you get a secondary rainbow, this is what's happening in those rain droplets. Okay, here we have the incident ray, or the sun's rays coming in. Notice we have refraction right here. We have reflection right here, and actually we have reflection twice. And then it comes back out and it's refracted again. So there's the person's eyes down there, and it's the secondary rainbow would look above the primary rainbow. So here we have the primary rainbow and the secondary rainbow over Stonehenge. Very pretty.